For today's lesson, our learning objectives are the following. First, define what is a circuit and the different types of electrical circuits. Second, solve circuit problems. And lastly, cite some applications of electrical circuits in our daily life. It is really important for us to know the definition of electrical circuits and what are the components of a circuit. So when we are talking about electrical circuit, it is a conducting loop in which current can transfer electrical energy from a suitable source to a useful load. Here's an example of a simple circuit, and let's have the different parts of it. First, we have the source or the supply. Source and supply provides the voltage needed to force current through the circuit, followed by the switch, which continues or discontinues the flow of electrical current. Third, we have the load, which is any device that converts electrical energy into some useful forms. And lastly, a conductor, through which the current travels. These are usually the wirings that we have. For us to have an easy way of writing or drawing the circuit, so it's very much important that we know the different component of a schematic diagrams of circuit. First, we have here the voltage source. So the longer lines represent the positive terminal of the battery, while the shorter one is the negative terminal. Second, we have the switch. So when the lines are not joined, the switch is open and the current flow through the wire is not available. Third, we have the bulb. And next, the resistors. So resistors do not have polarities. And capacitor, this the curved line represents the negative terminal of the capacitor. And lastly, the fuse, which is very much important for some appliances because it controls the regulations of electrical current in our appliances. There are different ways on how we connect the wirings at home. So the first one, we have the series circuit. So series circuit has two or more loads and current flows through a single conducting path. This is an example of a simple series circuit, and if we're going to put it into schematic diagram, this is how it looks like. Notice that here, the longer line, which is the positive terminal of the battery, is the source of our electrons. So as you can see, the movement of electrons here is from the positive terminal going to our resistors, then going back to the part of the battery which is in negative. So these are the formulas for series circuits. So let's have an example for a series circuit. So I have here the schematic diagram of four resistors connected into 25 volts batteries. So let's try to find the total resistance, amount of current flowing in each device, the voltage drop across each device, and the power across in each resistance and the total power. So first, let's have the RT. So we have here R1, R2, R3, and R4. And based in our formula for resistance or total resistance, so we have R total is equal to the summation of all the resistors in a given circuit. So R1 plus R2 plus R3 plus R4. So we have 65 ohms plus 84 ohms plus 73 ohms and lastly plus 10 ohms. And we have here 232 ohms. And following the two digits after the decimal, our final answer will be 232.00 ohms. Okay, so we're done with the total resistance. Let's have now the current. As we all know, the I total is also the same with our summation of I1, I2, and I3. Meaning to say, if whatever we have for I total, that is also the current flowing for each device that we have. So based on the Ohm's law, we can solve I total using the formula I total is equal to V total over R total. In our schematic diagram, our V total is 25 volts. So we have 25 volts over 232 ohms. So we have here 0.11 ampere, our current. Now, so we're done with the total current. So our I1 is equal to 0.11, I2 0.11 ampere, same with I3 0.11 ampere, and I4 0.11 ampere. So these are the four currents that we have. Next, let's have the voltage drop for each device. So we need to solve for the V1, V2, V3, and the V4. So sa V1, we can use the formula V1 is equal to I1 R1. So we have 0.11 ampere times 65 ohms. So the answer will be 7.15 volts. For V2 naman, we have I2 R2. So the same 0.11 ampere times 84 ohms. So we have 9.24 volts. For B3, we have I3 R3. So 0.11 ampere times 73 ohms. We have 8.03 volts. And lastly, for the V4, we have I4 R4. So 0.11 ampere times 10 ohms. So the answer is 1.10 volts. Now let's try to solve for P1, P2, P3, and P4. So for P1, P2, P3, and P4, we can use the formula for power, which is P is equal to IV. So since we have voltage and current here, we can use this formula. Although we also have other formulas for power, but we can also use that for this problem. So we'd use I and voltage for this problem. So P1 is equal to I1 B1. So we have 0.11 times 7.15. So we have here 0.79 watts. Your P2, I2 V2, 0.11 times 9.24. So we have here 1.02 watts. For P3, we have I3 V3, 0.11 ampere times 8.03 volts. So we have 0.88 watts. And for P4, we have I4 V4, so 0.11 ampere times 1.10 volts. So we have 0.12 watts. And for our total power, so P total is equal to P1 plus P2 plus P3 plus P4. So using our calculator, we can solve this. So we have 0.79 plus 1.02 plus 0.88 plus 0.12. So we have 2.03 watts. Our P total, 2.03 watts. So let's have another example of electrical circuit. Now let's have the parallel circuit. So parallel circuit has more than one path of current to flow. This is an example of a parallel circuit. And if we're going to put it into a schematic diagram, this is how it looks like. As you can see dito, mga anak, meron tayong flow ng current sa iba't ibang resistors. So meaning to say, hindi na aantala yung pag-flow ng current natin kapag may napunding isa. A good example nito yung mga electrical connections natin or wirings natin sa bahay. So as you can see, kapag for example, may isang naapektuhan, so the other appliances will still function. And these are the formulas for the parallel circuit. So as you can see, let's focus on the voltage that we have here. So compared to series kanina, you need to get the sum of all the voltage. But here, your voltage total is the same with your V1, V2, and V3 as a value. And para naman makuha yung R total natin, kailangan natin i-divide yung 1 nung sum ng mga ng resistors natin na given. And for the power naman, same pa rin yung formula natin, just like what we have in the Ohm's law. So, apply natin to into a sample problem sa susunod na slide. Let's have an example for parallel circuit. So, I have here 3 resistors connected to our source, which is 9 volts. So, we have 90 ohms, 45 ohms, and 180 ohms respectively. So, for us to get for the R total, which is as in the first one, so 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, since we have only 3 resistors connected here. So let's substitute. So we have here 1 over RT pa din is equal to 1 over 90 ohms plus 1 over 45 ohms plus 1 over 180 ohms. So, ang sagot natin dito will be 0.0388 and so on. So, para makuha natin yung R total natin dito na value, divide natin yung 1 by the answers that we got here. So, therefore, ang magiging final answer natin for R total will be 25.71 ohms. So, ayan dapat yung lalabas sa calculator ninyo. So, ang gagawin lang, 1 divided by the R resistance total that we have. So, tandaan yan para makuha natin yung R total value natin. Next, let's try to solve for our current flowing for each device. Take note, sabi natin sa parallel circuit kanina, our voltage from B1, B2, and B3 or the voltage drop will be the same with our source. So therefore, your V1 here, di na natin kailangan isolve yung B1, B2, and B3 or yung voltage drop dito. Kasi based sa formula natin, pare-pareho lang siya. So we have here 9 volts. Our B2 natin will be 9 volts also. And B3, 9 volts. So try natin solve yung current one natin. So we have B1, R1. So we have 9 volts over 90 ohms. So kapag dinivide dyan, ang lalabas nating sagot ay 0.10 ampere. For I2 naman, we have V2, R2. So we have 9 volts over 45 ohms. So we have 0.20 ampere. And for our I3, we have here V3 R3. So maging sagot, 9 volts divided by 180 ohms. We have 0.050 ampere. So these are our I1, I2, and I3 values for this circuit. Now next, let's try to solve for the power across each resistors. So for the power for each resistors naman, we still use the formula P is equal to IV. So since meron tayong tatlong voltage values and current values, so therefore for P1, we have I1 times voltage 1. So ulit natin, I1 B1. So we have here 0.10 ampere times 9 volts. So we have 0.9 watts. Second, we have P2. So I2 V2. So we have here 0.20 ampere times 9 volts. So we have 1.8 or 1.80 watts. So 0.90 to. And P3, we have I3 B3. So we have here 0.050 ampere times 9 volts. So ang sagot natin dito ay 0.45 watts. And to make it clear, so let's use the highlighter first. Yan. So I do hope na nakikita nyo siya. What if our electrical circuit is connected into a series parallel connection? So we have here an example. So we need to find the total resistance and the total current of all the four resistors connected in a combination circuit. So we have R1, which is 30 ohms, R2 25 ohms, R3 35 ohms, and R4, which is 40 ohms. So first thing that we must do is to combine R2 and 3 para magkaroon tayo ng isang series connection na lang. So, i-re-rate natin siya or re-redraw natin class yung circuit natin. It will be looks like this dapat after the combination of the resistors na nakaparallel. So, ganito yung magiging itsura niya. So, yan. Ito yung magiging R1 natin. Ito magiging R2 and 3. And this will be R4. So, let na natin yung value ng R1 natin. R1 natin dito still 30 ohms. R2 and 3 still unknown. In R4, we have 40 ohms. Next. So, first thing that we must do is to solve for the R23 value. So, using the parallel formula for resistance, so we have 1 over R total or R23 na natin kasi nga dalawa lang naman sila. So, equals to 1 over 25 ohms plus 1 over 35 ohms. So, same process on what we did in our previous example for parallel circuit. So, una, kunin muna natin yung summation ng R23. Then, next is yung sagot. Yung 1, i-divide natin sa magiging sagot nito. So, if we're going to solve that, we have here 14.58 ohms as our R2 and 3. So, meron na tayong 14.58 ohms values dito. Yan. Next, since meron tayong R2 and 3, pwede na natin isolve yung R total natin using the series formula for resistance value. So, R1 plus R2, 3 plus R4. So, substitute lang natin 30 ohms plus 14.58 ohms plus 40 ohms. So our total will be 84.58 ohms. So this will be our R total. Now, speaking of current, sa series connection natin, I total is equal to I1, is equal to I2, is equal to I3. So meaning to say, kung ano man yung I total natin dito, yun din yung I1, I2, I3 values na pumupunta dyan sa mga resistors natin. So for I total, using the Ohm's law formula, I total is equal to V total over R total. So substitute lang natin. So for our V total, we have 10 volts. So 10 volts divided by 84.58 ohms. So ang ating I total will be 0.11 ampere. Yan. So I do hope you learn new things to these lessons and makatulong ito sa inyong discussion about sa series, parallel, and combination circuits. Thank you and God bless.